We have an analysis here to do about on a particular sample of salt. This is that sample G is an inorganic compound. Carry out the test below and record your observation and inference. Now, these are the tests they are going to test. We're going to carry out. In this test, we are to find out the anions and the cations in the compound. So in this one, say that G plus water, shake and divide into three portions. So by adding water to it, what we observe is our observation is that we have a green colored solution. A green colored solution, that is what we have. And having a green color solution means that we have transition ions. Transition ions is what we have, and some of them that can give us green color is example of that ion is copper 2 ion, iron 2 ion. These are some of them that can give us green ion likely present. Likely present because we don't really know the salt that is the ion that is there, but we know that the ions that can give us green color in solution, the possible ones are copper ion and iron 2 ion and some other ones. So now in this in the first portion here, it said that add aqueous ammonium solution in drops, then in excess. Now what we observe in that, when we add aqueous ammonia in drops, we have dirty green gelatinous precipitates insoluble in excess. Dirty green gelatinous precipitate insoluble in excess. The precipitate is insoluble in excess. And so for the fact is insoluble in excess and the dirty green gelatinous precipitate, what we have there should be ion 2 likely present. Ion 2 is likely present in the solution. So the next thing we do here, the second portion, that's what we have here. Second portion, add dilute sodium hydroxide solution in drops and in excess. When we add in drop, we notice another dirty green gelatinous precipitates insoluble in excess. Insoluble in excess. That confirms the presence of, that means ion 2 ion confirmed. So the last one we're going to do here is the third portion. We're going to look at what will happen in the third portion. So to the third portion, we add dilute silver nitrate solution. On adding dilute silver nitrate solution, what we have is a white precipitate. Because we have, for the fact we have white precipitate, we know that silver has two white insoluble white precipitate, which is from carbon, triazo carbonate, and also that of the chloride, chloride ion, the chloride ions, and triazo carbonate ion. These are the two possible um, white precipitates or insoluble ion of or insoluble compound of what? Silver. The ones that are white in color is triazo carbonate or chloride. Now there are some. So for that reason we are suspecting triazo carbonate and chloride ion. But there's something that happened here on exposure. On exposure to sunlight, the white precipitate, the white PPT precipitate change darkens a little. Darkens, that means since it darkens like that, it means that chloride ions likely present. So for the fact is this, well, like I said earlier on, for the fact is white precipitate, it means that triazo carbonate and chloride ion are what? Likely were present. They are likely present. And for the fact it darkens on exposure to sunlight, it means that chloride ion is likely present. So to the mixture above, that the mixture we have from here, we add dilute triazole 5 acid solution. On adding dilute triazole nitrate 5, we notice that the precipitates remains insoluble. That means it's still insoluble in dilute triazole nitrate 5 acid. Now for the fact is it's still insoluble in dilute triazole nitrate 5 acid means that what we have there is what? Chloride ion. Chloride ion is there. So now one thing is sure is that if is triazo carbonate would dissolve in acid to liberate carbon 4, and then at the end of the reaction it will be soluble. So but now because it does not contain the G does not contain the chloride ion, does not contain carbonate, that is chloride ion. That's why the precipitate remain, because chloride ion, the precipitate of silver chloride is insoluble in triazo nitrate 5 or nitric acid. All right, thank you so much.